All right, wonderful. Let me move on to assessing relationships between variables. And now we're going to switch to talking about the workhorse of social research, which is the model called the linear regression model. How many of you have ever heard of something called a regression? How many of you have never heard of this? This is great. So I don't have to, I can really talk about what's going on with the confidence that you guys have at least heard about this, right? So slide number 50, please. In the past, right, in last 10 minutes, last 15 minutes, we've been talking about relationships between a categorical independent variable and a continuous or quantitative dependent variable. That's a mistake on the slides. It should be DV, not IV. Okay? Again, the independent variable was categorical. The dependent variable was quantitative. Now we want to move to summarizing relationships between two quantitative variables. And to do this, we need to think carefully about the concepts of correlation and regression because they work hand in hand, all right? But part of our concern is now talking about how one variable is quantitatively associated with another variable, all right? Quantitatively associated. And to do this, you've got to remember from high school where you were taught what is an X coordinate and what is a Y coordinate, or an X axis and a Y axis, okay? All right, slide number 51. Please, everything in research begins with thinking about relationships. Again, this is just a review. And relationships logically, again, flow from left to right, okay? X is the independent variable, Y is the dependent variable. And our goal is to establish a conceptual relationship, right? Find evidence for a conceptual relationship and support that evidence with statistical information. Okay? Slide number 52. In quantitative research, the tools that we use to assess these relationships depend on how the variables are measured. All right? Now, I am going to show you a tool for measuring the relationship between two quantitative variables. One, a quantitative independent variable, and one, a quantitative dependent variable, okay? And this tool is called a regression, it's called regression analysis, okay? So slide number 53, moving them just a bit quickly because I know you guys have this, right? There's several aspects of regression analysis that you need to be aware of. First, the first step to do this is to investigate whether an association exists, right? You want to figure out, is there an association between these two variables? And to do this, we use a technique called a correlation. A correlation is a statistical technique for assessing a relationship between two quantitative variables. But this is important. When we're using a correlation, right, and that correlation spits back a number at you, and that number ranges between 0 and 1 in absolute value, right? But that number, right, merely talks about the strength of the association between two variables. But if we want to figure out much more than the strength, but if we want to talk about the nature of the relationship, we need a technique called regression analysis, because regression analysis is a technique for talking about not only is there a relationship, but how much explanatory power does the independent variable have in explaining the dependent variable? How much explanatory power, okay? So here's how we do this. Slide number 54. Let us denote Y as representing our dependent variable. Again, this is probably the 4th time I've said this, but I use repetition in my teaching technique so that you guys can get this, right? So let's let Y denote a dependent variable, and let x denote an independent variable. And we are interested in how y varies according to values of x. We are interested in how y varies according to values of x. In other words, we want to know how y, the dependent variable, changes as a linear function of values of x. And that linear function is this: y for each individual, that's what I mean by y sub I, for each individual, is said to be a function of a plus bx. That's the formula for a linear regression. And I'm going to walk you through exactly what that means. All right? So whenever you see y equals a plus bx, what should pop into your head is that's the notation for linear regression. And here is what we mean by these linear functions. Y equals a plus bx. Turn the slide, next slide, please. Slide number 55. Y equals a plus bx, where a represents an intercept, right? B represents a value that denotes the nature of the relationship between x and y, and x represents the actual value of the dependent variable, of the independent variable. Once more, A is called an intercept, B is called a slope, or a value that represents the nature of the relationship between x and y, and x is the actual value of the independent variable. Now let's pull that all apart for you. I'm not expecting you to know what this is. I'm just going to introduce this to you and explain it to you as best I can. The intercept, or A, is the point at which the straight line or the slope touches or intercepts the y-axis. That's what the intercept is. That's one way of defining it. It is the point at which the slope or the straight line, again, I'm talking about XY coordinates, and the straight line is the line that represents the relationship between X and Y, right? Wherever that line touches the Y-axis, that is called the intercept, where it intercepts with the Y-axis. That's one way of thinking about what an intercept is. But it has another interpretation. The intercept is the value of the dependent variable when X is equal to 0. Let me stop right here. If you look at that relationship, Y equals A plus BX, what would happen algebraically if X was equal to 0? Taking you all the way back to high school algebra. Y would be equal to A if X was equal to 0. Why would that be? Anything times 0, right, cancels out from high school algebra. So by definition, the intercept, or A, is the value is equal to Y, right, when X is equal to 0. Okay, and the slope, which is B, is the steepness of the line that signifies the relationship between X and Y. Now that line can either slope upwards or it can slope downwards. If it slopes upwards, you say that the relationship between X and Y is positive. And if it slopes downwards, you say that the relationship between X and Y is negative. And if it is negative, then B, or the slope, would be a negative number. It would be a negative number. And don't worry, I'll give you plenty of examples for what I'm talking about. Okay? But I just needed to define terms before I put meat on the bones of these terms. Okay, everybody with me so far? Don't worry, we're almost done. We're almost home, don't worry. Almost home, I promise. All right, slide number 56. Again, B is called beta in the technical literature. B stands for beta, or the slope. And again, it is the change in Y for 1 unit increments in X. When X increases, what happens to Y? Does Y go down or does it go up? One more time, when X increases, what happens to Y? Does Y go down or does it go up? All right, so for any two values of X that differ by 1, Y will differ by whatever beta is. So here's an example. Here we have a regression equation where Y is equal to 3. And what is 3? The intercept. Y is equal to 3 plus 2x. Okay, and what is 2? The 2 is the slope. Okay, one more time. 3 is the intercept, 2 is the slope. Okay, if X is equal to 3, then Y is equal to 9. If X increases by 1 unit, then Y is equal to 11. The difference between 9 and 11 is the slope, or beta. One more time. The equation is Y is equal to 3 plus 2x. 3 is the intercept. 2 is beta. X are possible values of the independent variable. If X is equal to 3, then mathematically, Y works out to 9. If X increases by 1 unit to 4, then mathematically, Y works out to 11. The difference between 9 and 11 is the value of the slope, which is beta, which is 2. And beta describes the rate of change in Y for 1 unit increases in X. Let me say that one more time. Beta describes the rate of change in Y for 1 unit increases in X. The rate of change in Y for 1 unit increases in X. Everybody see that? Great. Move forward one slide. 57. The intercept, or alpha, and beta, the slope, are directional. Okay? If beta is negative, 1 unit increases in X produce decreases in Y. Just walking you through definitions now, right? If beta is positive, or if the slope is positive, 1 unit increases in X produce increases in Y, all right? And a slope line can be flat, suggesting no relationship between X and Y. Okay, so no relationship, the slope looks like that. Positive relationship, the slope looks like that. Negative relationship, the slope looks like that. Okay, and the differences in magnitude, right, in terms of how flat or how positive really are reflected in the values of beta. All right. Now, I have a definition here of what alpha, or the intercept, is that I've already talked about, but the last sentence is really crucially important here. Really important. This relationship, this linear relationship, is in equation form, and it is a model. It is a statistical model. But this is important. That statistical model has to reflect a conceptual model that you have in your own mind. They have to go hand in hand. Okay, so that statistical model must match a conceptual model or story that you have in your own mind. And let's now use an example, because a picture is worth 1,000 words, and so is an example. I'm looking at the relationship, slide number 58 now. The relationship is between sexual initiation and education. And here is the question I want to ask. What is the relationship between age? What is the relationship between the age when people initiate sex and the years of completed education? What's the independent variable? What's the independent variable? And what's the dependent variable? Okay, you sure?
Well, for me, well, it depends what you're asking. I want to know, how does the years of completed education impact on the age when people initiate sex?
Is that how I asked the question?
Well, depends. Well, you can have, okay. So if you're asking the question, how does the age when people initiate sex, okay, impact on their years of a completed education? Okay.
All right. So notice there is no right answer here. The answer is, how did I ask the question? Right? And how I ask the question is up to me, the researcher, to decide. Right? You have to be in complete control of the story, because the tool that you use, whether it be Stata or SPSS, does not care one way or the other. It will give you a relationship, but the relationship has to make sense. Here's a story I wanted to tell. How young or old you are when you initiate sex influence your socioeconomic status later in life? That's what I want to tell to the reader. Notice I framed it in a conceptual way, right? I imposed upon the data that the independent variable is age at sexual initiation and the dependent variable is sex. I did that. Stata did not do that. SPSS did not do it. I did it. I could have done it the other way if I wanted to tell that story. Okay, but it's totally up to me. So again, in this specific example, the independent variable is age at first sex, the dependent variable is education. Both are quantitative variables. And it's important that you understand that both are what we call quantitative or continuous variables, okay?
Sorry. So you're asking how does the years of completed education impact? No, you're asking about how the age of sex impacts on completed education.
Yes, yes. Now, again, that's how I asked the question, right? But you're asking the question the other way may be much more conceptually interesting to you, right? This is just an example, okay? So skipping slide number 59, right? I'm using the same data, and this is observational data. Skipping slide 60, right? Again, moving quickly through slide 60, we're going to describe the data, conduct a regression, and then interpret the results. Slide 61 is just the description of age at first sex. You've already seen that. Slide number 62 is the distribution of education. Similar kind of interpretation to age at first sex. I won't waste time with that. I want to slide number 63. Okay, everybody look at what we have here. The command is reg dependent variable, then independent variable. And we have some results that I want to walk through with you. The first thing to understand is that I want you to remember the structure of the equation that I taught you. Y is equal to A plus BX, where A is the intercept, B is the slope. In this output, underscore CONS is equal to A. Once more, in this specific output, underscore CONS, or the constant, is equivalent to A. It is the intercept. Okay? What?
Another way of saying intercept is constant.
Yes. How do you interpret what this constant is telling you? The dependent variable is educational attainment. Can you talk about what it is telling you in words? Force yourself. The question is about the constant or the intercept.
I'll start with the question.
How do you interpret the intercept?
So we're trying to find out what the intercept is, so where the y-axis is.
So remember, the intercept has two interpretations. Where it intercepts with the y-axis, and what's the other interpretation of the intercept? Can anybody remember? When x is 0. All right. So let's actually stick with that second interpretation. Can you directly interpret the intercept for me? And you're talking about the intercept in terms of how the dependent variable is measured. The dependent variable is measured in years of completed education. So interpret the intercept for me, somebody. And just to help you out, that intercept is 3.49. All right? How do you interpret it? You want me to help? Or do you want to figure it out on your own?
That's the first number on the y-axis.
Don't think of it as the y and x axis. Use the second definition I gave you. And that second definition is on, just to be clear.
The age of 6.49 years of education, something like that.
All right, let me help you out. Let me start you off. 3.49 is the number of years of completed education when once more. Yep. The question is, how do you interpret 3.49? What does it mean in words, in actuality? And I started the sentence for you. 3.49 is the expected years of completed education when
someone gets initiating sexual activity.
When plausibly somebody initiates sexual activity when they come out of the womb at age 0. When age for sex is at 0. So if you initiate sex very, 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 very early, you're expected to earn how much years of completed education in the future? if you initiate sex at a very, very, very early age, the earliest age plausible, which is, I don't know, at birth, let's say it's plausible to do that. How much education are you expected to earn in the future? That's a very small number of years of education, right? But that's the interpretation of 3.49. It is the value of the dependent variable when all independent variables are 0, or when the independent variable is 0. In this case, when age at first sex is 0. All right. Now, it's difficult for you to think of age at first sex being 0, but what this is saying, just forget about that. It's just saying when that value is 0, that's the expected years of completed education. Okay? Here's something harder. The relationship between age at first sex and education is 0.243. What do you think that means? And I'll have to help you out with this one. The relationship between age at first sex, the independent variable, and the dependent variable, right, is 0.243. And the question is, what does that 0.243 mean? Here's what it means. Write this down. For every 1 year increase in age at first sex, education, future educational attainment increases by 1/4 of a year. For every 1 year increase in age at first sex, future educational attainment increases by 1/4 of a year. So every time you increase age at first sex by 1 year, you also increase future educational attainment by 1/4 of a year.
Because your graph's not going to start with your line is not going to start.
Your line is going to start at 3.49 and increase from there.
But your x, you're not going to start plotting anything on the x-axis from 0, because you're not going to have anybody who's having sex at 5 or 6 or 7. You might have your first, say you have your first 6 or 12.
Yep.
So that means your line will only start on the x-axis at 12.
Your line you mean on the y-axis or?
Well, on the x-axis.
Okay, so go back to slide number.
For age of your education, sorry.
Yes.
And then your y-axis. Okay, so your lines are going to start at 12.
So you're plausibly, right? Look at slide number 61. Everybody see slide number 61? What is the smallest value of age at first sex? It's a plausible 8, is it not? Everybody see that? So you could start there. All right. So basically what you're asking yourself is, from the age of 8, right? Or whatever from the age of 8, what happens to age at first sex? It increases. I'm sorry, what happens to future educational attainment? It increases for every 1 year. Okay? Now, yes. No, that's fine.
If the age at first sex is going to be the dependent variable.
Age at first sex is not the dependent variable, it's the independent variable.
Yes. Sorry. And education is a dependent variable.
Yes.
And education will be on your x-axis.
Education will be on the y-axis. Education will be on the y-axis. On the x-axis is age at first sex. Independent. Yes. Got it? Yes, right. Dependent y. That's the way to think about this. Yes. The slope is 0.243. Correct. That's B or beta. That's the slope.
formula here will be y equals 3.49 plus 0.343.
Correct. Correct. So again, this is really important that you understand. He just stated the equation. The equation is, write this down. Everybody write this down. Y is equal to 3.49 plus 0.243x. Everybody got that? One more time? You want me to say it one more time? Anybody need it one more time? All right, y is equal to 3.49 plus, and we're using plus because the direction of the relationship is positive, plus 2.43x. Yes. Wait, was that smile because a light bulb came on?
As my age.
At first sex.
Oh, your education will, yes.
You got it? Good. Question. No, this is important to get because everything, every other complex topic as it relates to regression builds off of this. Right? Once you got this, you got everything. Okay? And the other thing I want to make sure you understand is that I'm leaving this book right here with somebody. This, everything that I and more that I talked about today is in this book, and I'm leaving this here. Okay, so just make sure you get it. But anytime you need to consult it, it's right there. I have now some slides that I wanted to talk about from the message I got yesterday. Wonderful. Yes. Wonderful. What time is it? What is it? Okay, so I have some time to do this, right? Because lunch is 1. Wonderful. And then we'll end this teaching session at 1. So let's go to slide number 64. And before I talk about this, I want to make sure that I cover some things.